Hi there, and welcome back to lesson 20, believe it or not, of the Dead Earth game development series, brought to you by myself, Gary Simmons, and the Game Institute. Now, in this lesson, after 5 pretty rigorous lessons where we wrote lots of code that we were unable to test or see the fruits of our labor, we're going to start writing the actual scripts, such as the idle state, the patrol state, etc., that we can drag onto Zombie Jill and start to see something happening on the screen in response to all of our hard work. Now, you are reminded that if we open up Omni Zombie Jill, so that we see her child hierarchy and we select the AI entity game object, it's this game object that contains the animator, the capsule collider, and indeed the AI zombie state machine itself. But we can see if we look in her inspector that although we've configured her state machine to start off in the idle state, we have added no child states to Jill yet. So when the zombie state machine starts up and it tries to search for the states on its game object, it's not going to find any. Now, of course, we've written quite a lot of the plumbing for our child states that we're going to write from here on in. We wrote the AI state class, and we wrote the AI zombie state class, which is derived from AI state. And they contain a lot of the shared functionality that is going to be used by all of our states. But they were abstract classes that didn't implement all of the functions that were laid out in the AI state class. So, for example, if we go into the assets folder in our project view, drill down into the Dead Earth folder, into the scripts folder, and into our AI folder, there is our AI zombie state class that we wrote in the last lesson. But you'll see if I select Jill's AI entity game object and then try and drag that AI zombie state onto it, I'm going to get an error. And that's because we can add AI zombie state because it is an abstract class. It isn't a complete class yet. So what we're going to do first of all in this lesson is we're going to write the first actual fully complete child AI state, which is going to be the idle state. Now, the idle state is the most simple state of all. It basically just sets the speed of the zombie to 0, which is going to cause in its animator, we call up Jill's animator, it's going to call the idle animation clip to play, and it's just going to stay in idle for some period of time that we are going to specify in the idle states inspector. And then once that time has expired, the idle state is going to transition out of that, and the zombie is going to transition into a patrol state where it's going to start patrolling waypoints in its AI waypoint network. However, although the idle state is a very simple state, it's a great first state for us to write because we get to see how these states plug into the system as a whole that we've written so far. We get to see how the state machine interacts with the state, and we also get to see what the state does with respect to examining the audio and visual threats that have been compiled in that update and how it uses those to transition out into different states. So what I'm going to do, first of all, is I'm going to go into my scripts folder, which is inside my assets/Dead Earth folder. I'm going to drill down into my AI folder where all of my AI scripts are. I'm going to right click, and from the context menu that pops up, I'm going to create a new C# script, and I'm going to call this AI zombie state underscore idle 1. Now, why do I call it idle 1 and not just idle? Well, because the nice thing about this AI system is that you might create 20 different zombie idle scripts that all behave in completely different ways. And this system doesn't care. You can drag and drop them onto the various objects in your world to have the zombies behaving in different ways. So I like to call all of the states that I create with a 1 on the end so that later on if I create a second version or a third version or a fourth version, I know which one is which. So I'm going to open up now AI zombie state idle 1 in MonoDevelop. And the first thing we're going to do is we're going to remove that boilerplate stuff. We don't really need that. In fact, our states are only really derived from mono behavior so that we can add them to a game object, but we don't implement any of Unity's magic functions such as start or update. So there's never a case where functions in our child states are ever directly called by the Unity engine. So I'm going to delete those. And of course, AI zombie state idle 1 is not derived from mono behavior. It's not even derived from AI state, it is derived from AI zombie state, which of course is itself derived from AI state, which is itself derived from mono behavior. So if I save this off now and go back to Unity, you're going to see we get an error. And the reason we get this error is that this is not an abstract class like the AI zombie state class and the AI state class, which means that we need to make sure that all of the functions that are laid out in the AI states interface are implemented. And we know we have at least two which aren't implemented. We have the get state type function and the on update function. So we're going to need to implement some function bodies for these in all of our derived classes. Now, get state type function, just to remind you, this is a function that is called by the parent state machine when it first fetches the state from the game object at startup. And the reason it calls this function is it's basically saying to the state, what type of state are you? That state can return, hey, I'm the idle state, I'm the patrol state, whatever. And if we go to the AI state machine file and scroll up to the top, you can see that we have that AI state type enumeration defined there. We did it a few lessons ago, and currently it supports, idle, alerted, patrol, attack, feeding, pursuit, and dead, but we will no doubt add more types of state to that as we flesh out our zombie system. So in the case of our idle state that we're writing now, we want this to return AI state type idle. And then what the state machine will do is it will say, hey, this is the idle state, and then it will use that AI state type idle to store it in a dictionary. AI state type idle becomes the key, and of course the value in that dictionary is the actual state itself, a reference to our AI zombie state idle 1 object. By the way, I'm sure you know this, but the reason we didn't get errors like this when we were creating our AI zombie state and our AI state classes is that both of those classes were described as being abstract classes. So we were letting Unity know that, hey, we don't expect this to be a fully complete class yet. There's going to be derivatives of this that are going to fill in the missing pieces. But in the case of our idle state, it's not an abstract class. We need it to be directly instantiatable. We need to implement those missing functions. So I think I'll go back to the AI state base class and I'll copy over both of those methods now, so I don't have to remember what the signatures are, and we will paste them into the body of our idle class like so, changing abstract to override like so, and we'll put some function bodies in there as well. So of course, for the get state type function, we just need to return the AI state type, which most closely resembles the type of state this is. So we'll just simply return AI state type idle like so. And what I'll do, just so that we can see when we press play that this mechanism is working and that it's being correctly called by the state machine, is I'll put a debug log in there. Okay, and that is that function done. All of the get state type implementations and all of our states will literally just be this. So when we're creating our patrol state, that will return AI state type dot patrol, and when it's the attack state, attack, and you get the idea. Now, the other function that we have to implement, where most of the cool stuff is going to happen in our other states, is on the on update function. This is called by the state machine with each update so that the current state has a chance to do what it wants to do. Now, the reason it returns an AI state type is you are reminded that when any state wants to transition into another state, it simply returns a state type from its update function that is not its own state type. And if it wants to stay as the state with focus, then it just returns the state type that matches its own state type. So just to remind you where that happens, if I call up our state machine and scroll down to the update function, like so, you can see that right at the top of that function, assuming we've got a current state, so let's assume that everything is started up correctly, and now our idle state is the current state that this reference is pointing to. Then the first thing the update function does is it calls the current state's on update function. That allows the state to do whatever it wants to do, but it also returns the state type. And what we say is if the state type is different from the current state type, then this state is trying to indicate to us that it would like us to transition into a different state. But if it does return its own state type, then none of this happens, and all this function does is literally just call on update. So what we'll do is we'll go back to our idle state, and for now we'll simply return AI state type idle, like so. But of course, it's in this function in a moment that we're going to look at the audio and visual threats, and based on what they tell us, we may return something different from this function. We may return attack or pursuit or patrol. And from the code we just saw on the state machine, we know that that's going to cause a transition from this state into the new state. So even with just this bare framework in place, things should start working now. Okay, so with Zombie Jill's AI entity selected, what we can now do is we can now drag our AI zombie stay idle script onto Jill. And if I close up some of the other things on Jill so we can see things a little bit better, we can now see that we have our state machine and we have our first state. So when we press play, the state machine is going to find that this script is on its game object. It's going to examine it. It's going to find out it's the idle state, and this is going to be the current state that we want to start in. And then with each update, it's going to be calling this script, the idle script update function, which we know at the moment does nothing except return idle, indicating to the state machine that we want to stay in the same state. So when I press play now, we should just see Zombie Jill stuck in our idle animation, and we should see in our animator that we're just in the idle state indefinitely. Oh shit. Oh, the moment I've been dreading has come to pass. Where all of that code I've been writing for the last 5 lessons, I press play and it doesn't work. Well, we can see straight away that she's not staying in the idle state, she's in the locomotion state. And we can also see in the game view that Jill is in the locomotion sort of animation. So that was hideous. And not only that, I also had an error here. Well, first of all, why is the get state type function being called twice? That's called from the state machine in its start function, isn't it? Let's have a look at that. Oh yeah, actually that is correct. It should be getting called twice, because you'll notice that once we've fetched all the states from the game object, we then loop through all of those states, and we first of all call get state type just to make sure that that state type doesn't exist in the dictionary, and then we use it again to store it in the dictionary. So it's perfectly okay that that function is being called twice. It's not being added to the dictionary twice, but we've also got a null reference exception here in the set state machine function. Once again, you're reminded that from the AI state machine's start function, once it stores the state in the dictionary, it then calls the state's set state machine function, passing in a reference to itself. So how can a reference to itself be null is the answer, is the question, should I say. So once again, if I call up where the set state machine function gets called, I can't see anything wrong there. Ah, I got it. Bloody hell. What a knobhead. Okay, so I'm sure you've probably spotted this weeks and weeks ago, because this function was done ages ago, right? So you've probably been sat there patiently waiting for this bomb to explode. But obviously this set state machine function is called by the state machine on its charged states to set a reference to itself, which it passes in this state machine local variable. And of course, the whole idea of this function, when it calls the base class, is to store this reference in its state machine with the underscore member. But what I've done is I'm actually using it prematurely. That's not supposed to have the underscore there. I'm supposed to be checking the type of the variable reference that we've passed into the function as the parameter, not its own internal storage of that reference, because we haven't set it at this point. If I delete the underscore, I do the check on the local variable that's passed in as a parameter, and then if it is of the correct type, AI zombie state machine, I then call the base class implementation, passing in that state machine reference, which then sets it internally, as you know, in its class member, in its underscore state machine. So that should get rid of that. I don't think that should have caused the locomotion behavior though. I think it's just one of one of many bugs. Okay, so we haven't got that horrible null exception reference anymore, but it's still going into locomotion. Let me press play again. Oh, that's strange. Well, you'll notice when I press play and press pause, speed is set to 1.6. Now obviously we haven't implemented all the code to the idle state yet. And one of the things the idle state is going to do in its on enter state function is it's going to set the speed of the state machine to 0, because we're not moving in a idle state. And we know that this will set this speed in the animator to 0, because that's what the state machine does, right? It takes the value that the state set and then passes it into the animator. And we also know, looking at these transitions, that when the speed drops below 0.5, it's going to drop down into the idle state. So if I did implement the code to the on state enter function that set the speed to 0, then this wouldn't have happened. However, I've just realized where this 1.6 is coming from, because that was the thing that was confusing me. And of course, what I did in a previous lesson is I said that in the state machine, we won't store a separate variable for speed. We'll just use the nav agent speed to store and fetch that variable from. And if I select Jill's AI entity and unfold the nav mesh agent inspector, you can see the speed is indeed set to 1.6. So if I set that to 0 and then press play now, you can see that Jill is correctly in the idle state. Speed is 0 in the parameter list of the animator, and everything is working as it should. However, what this has done is it's raised a slight concern, and I've changed my mind about using the speed property of the navmesh agent to store our animator speed. Now, the reason I say this is because there may well be times in our states where we want to set the speed to 0, but we still want to know where the zombie wants to be heading to, where the nav agent should be heading to. And we saw in some of our earlier demos when we had Jill running around this level, that if we ever set the nav agent speed to 0, then the desired velocity vector would also be 0, and we wouldn't know which direction the nav agent is trying to head in. In fact, the nav agent wouldn't be trying to head in any direction because its speed is 0. We're telling the nav agent we don't want to go anywhere. And that could cause problems. So I'm actually going to, before we carry on with our idle state, I'm going to go back and I'm going to give our state machine, our zombie state machine, its own specific speed property. And I think what I'll always do with the navmesh agent is I think I'll always just set its speed to 1. And that way we know that even if we set the speed of the state machine to 0 so that the zombie is dropped down into the idle state, well then if the nav agent is being told to head towards a certain position or destination in the world, then because it has a speed of 1, it will always have a valid desired velocity vector, which of course is what we use to feed in to the animation blend tree. So yes, let me do that. So I'm going to go back to my AI zombie state class, and under the private variables I'm going to create a new private float called speed, which we'll set to 0 by default. And then we need to go and adjust those properties, don't we? Because we created this speed property here, which literally just fetched it from the nav agent or set it to the nav agent. So we're just going to use that speed variable we've just added now. So in the getter, we'll just return speed. And in the setter, we'll just say speed equals value. So that was me trying to be clever and causing a load of problems. So note to self, don't try and be clever. You're not a clever man. Stop trying to be something you're not. So we've added this speed variable now, just like any other variable, which is going to keep track of the zombie's current speed. And we've created the properties now that allow the child states to set that speed. And we just need to change the update function now, I believe, because in the update function, you can see that when we set the speed into the animator, we use the nav agent speed. We don't want to do that. We just want to use our speed variable. And now, if I go back to Unity, check I haven't got any errors, and I set the speed to whatever value I want, even if I set it to 100, if I press play now, it shouldn't alter the speed in the animator. The zombie is in idle, even without the idle state having to explicitly tell Jill to be at 0 speed. Although we will definitely get our idle state to do that. But the whole reason I've made this change is just that I'm a little bit worried that when we do actually want to set the speed to 0 of the zombie, how we had it before would then set the nav agent speed to 0, and then we would lose our desired velocity vector from the nav agent, which we use for determining rotations and things like that. So I'll set that back to 1. Okay, so we're back in business after a series of live recorded faux pas by myself. Only took 19 minutes. Okay, so let's now go back and start working on our idle class. I'm going to delete that debug log now from the getStateType function because we know it was being called. So what properties do we want our idle state to have? And I decided that the only thing I really wanted to have is a min and max time that the zombie can randomly choose when it goes into idle that it's going to stay idle for. So because I want a min and a max, I want 2 floats, so I'll actually create this as a vector that will make inspector assigned. So I'll say serialize field, vector2. I think I'll call this idle time range. And by default, I will set it to, I don't know, the min of 10 seconds and a max of, say, 60 seconds. And then we'll need some private variables now to keep track of this. So the idea being is that at startup, we're going to need to calculate a value between 10 and 60, or whatever these values have been set to in the inspector. So I will create a private variable of type float, and I will call that idle time. So that is 0 by default. And I will also create another float that we'll actually use to keep track of time, which I'll call timer. So when we transition into the idle state, what we'll do is we'll generate a random number between idle time range.x and idle time range.y, and we'll store the time that we've generated in our idle time private variable. So that's how long we're going to stay in idle if nothing more eventful happens before we transition out into a patrol state. And we're going to use a timer to keep track of it. Now, we saw many moons ago when we created our AI state class that there are several functions that we can override to tap into various parts of the transition process. And one of them is the onEnterState function. It doesn't have to be implemented in the child classes. It has a default function body in the base class. But you generally want to override this method because this is where you set up the state. So in our case, that's where our idle state is going to generate that random number for its idle time, set its timer to 0 and so on. So let's copy that out, and then we can paste that into our idle script. I'll put it between getStateType and onUpdate. I'll put it there. And of course, I will replace virtual with override, like so. So remember, going back to our state machine's update function, we can see that whenever we transition into a new state, where is that function? Where are you? There you go. Okay, so in the update function of our state machine, we can see that if we do have to transition into a new state, then one of the first things we do is we call exit state of the previous state, which doesn't apply the first time around, obviously. And then on the new state, we call onEnterState. So that's the first time we go into the idle state, that function is going to be called, and it's going to give our idle state a chance to do something. So just to check it's working, let's go back to our idle state, and in the onEnterState function, let's just do a debug log, and we'll put entering idle state. Dun, dun, dun. And then when I save that, press play from inside the editor, we should see in the console window, if I clear it, and there you go, one call to the onEnterState function, which outputs entering idle state. Then it just stays in the idle state because we haven't got any states to transition into at the moment other than idle. Okay, I'm going to leave that debug log in there actually because it's pretty useful, and we'll do that with all of our states so we can see when we're entering and exiting states correctly. So I think the first thing I'm going to do in here, just because it's well mannered, is I'm going to call the base class implementation. Now, of course, we know that the base class implementation of this function does absolutely nothing, but I like to call it anyway because it needs to be well mannered, because we may decide at a later date that we do want to add some stuff to the base class implementation. So I think we should call it just to be safe. I think the next thing we should do is just a little safety check and just say, look, if we haven't got a valid zombie state machine at this point, then let's just return because there's nothing we can do. And the next thing I'm going to do is I'm going to generate that random idle time. So I'll say idle time equals, and we'll use the random.range function, and of course the minimum range is idle time range.x, and of course the max time range is idle time range.y, and we'll set the timer to 0. We want to do things like this inside the onEnterState function, not just rely on it being set at the very beginning, because every time we go into the idle state, and we may go in and out of idle state many times throughout the life of this zombie, we want to make sure that the timer is reset and stuff like that. The next thing we want to do is we want to make sure that we configure the state machine now for the idle state. We give it the speed. We even tell the nav agent how we wish it to control our character. And we saw a few lessons ago that our state machine has a function called nav agent control. and it takes two booleans. It's just a way of us telling the state machine we want the nav agent to control our position and our rotation. Now, in nearly every single case, and we've covered this to death in previous lessons when we were creating our little demos, we're going to almost always have the nav agent controlling the position of our game object, but we're not going to have it controlling the rotation. The rotation is going to be controlled either via the root motion in the animation, or if we're in a running state and we need more accuracy, by rotating the object ourselves in our actual state, so we can make it face very quickly towards where it's supposed to be heading. So in almost every state that we implement, we're going to be setting the position update to true, meaning we do want the nav agent to update the position of our game object, but false for the rotation. Now remember, although we're saying the nav agent updates the position of our game object, it's not quite as simple as that, is it? Because it is responsible for updating the position of our transform, but it does that based on the velocity of the nav agent, which we override and set based on what the animator tells us is the root motion. So the animation speed drives the nav agent, really, and then the nav agent is just responsible for updating the position of the game object. Oh, it's all confusing, isn't it? So we're going to probably see this line in the on-enter state of all of our child states, but I don't want to assume it and hard code this in the zombie state machine, and that's why I allow each child state to turn on and off nav agent control on a per state basis. So we do want position update, but we don't want rotation update. Next thing we want to do is we want to set some of the properties of the zombie state machine. For example, we want to set the speed to 0. We also want to set seek direction to 0, right? Because we're not going to be seeking left or right in the idle state. That's seeking, isn't it? And we just set that to 0. Remember, that's the parameter in the animator, where if it's set to -1, we seek left, we turn on the spot left. If it's set to +1, we turn on the spot right. And we also want to tell the zombie state machine that we're not currently feeding, so we'll set its feeding boolean to false as well. Now, of course, you could say, well, we don't always have to tell it that, feeding is set to false, because if we weren't feeding before we went into the state, then we're just resetting a false value. But to be safe, you never know when you're transitioning into a state what you're transitioning from. So it's always a good practice to always make each state in its on-enter state function explicitly set the properties of the zombie state machine so that its behavior can be manifested visually correctly. I think there's one more thing that we want to do, which is if we've just transitioned into the idle state, then if there was any previous target that we were pursuing, we want to clear that target, because when we're in the idle state, it means there isn't a target. And of course, if we're in the idle state and then the visual and audio threats are processed again, then a new target will be set anyway in this state's update function. But when we first go into the idle state, we're going into that state because for whatever reason we've decided we no longer want to pursue any previous target, or there is no target. So we'll just say zombie state machine dot clear target. And if you remember, that was the function that we implemented when we first created our AI state machine base class, that just clears the target and disables the sphere collider, that little target trigger that we run towards. Because remember, the target needn't be a hostile threat, it could just be a waypoint that we're heading towards. And if for whatever reason we've decided that we no longer want to be on patrol, we want to drop out of patrol and stop heading towards a waypoint and drop down into idle, then we've dropped into idle, so we should clear that target. There you go. So these are all about configuring the state machine, and this is about kind of configuring the variables for this particular state while it's active. I'll just save that off, check I haven't got any errors, because let's face it, things haven't gone entirely well today for me on that front. Just press play, check nothing blows up. Yeah, we're in the idle state. And you can see that if before I press play I was to set feeding to true and I set seeking to -1, then the sheer fact that we've gone into the idle state turns those things off. Then there's probably some other things I need to set. I probably need to set crawling to false as well and set attack to 0. And this code block is probably something that we'll largely copy and paste into other states and then just tweak the values. By the way, we don't have to set crawling. You may remember from a few lessons ago, the crawling property is actually something that's managed by the state machine, not by a child state, based on damage that's been done to the zombie's lower half, its legs. So now let's work on the update function where things get more interesting. So the update function of any of our states really boils down to two tasks. The first one is examining the audio and visual threats and deciding whether a transition should happen to another state based on how they are set, or if the transition isn't needed, how that state continues to update the object. So in the case of, for example, when the object is patrolling and we're in the patrol state, that's going to be responsible for keeping the zombie's body rotating so it's looking towards its steering target. In the idle state, however, there is really not an awful lot to do. It checks the states and, based on how they're set, returns a transition into another state, and if a transition isn't needed, then it simply updates the timer. Now, of course, one of the conditions at which it's going to transition to another state is if the idle time is exceeded by the timer. So let's start by examining the visual threat first and checking if the visual threat is the most dangerous threat of all, the player. Actually, what I'll do first of all is I will just put at the top of this function a check that zombie state machine doesn't equal null. Right, so now we say if zombie state machine dot visual threat dot type equals AI target type visual player. This means that the threat is within our field of view, because we know that the base class will only set the player as a potential threat if it's visible and it's within the field of view. So that means that the zombie has seen this, and now we want to go into a pursuit state and just start running straight towards that threat. So we're going to set this as the new target. It's just a potential target at the moment. We want to call the state machine set target function. So we'll say zombie state machine dot set target, and fortunately we have a version of the set target function that just allows us to pass in an AI target type, which is what visual threat is. So we can literally just pass in zombie state machine dot visual threat. So now the important thing is, behind the scenes, when we do this, we know that we're not only setting this as the current target to head towards, but that's also going to cause our target trigger, that little sphere, to be placed at the target's position. And then, of course, we will then return. And what state do we wish to transition into if we see the player in our field of view? We want to return AI state type dot pursuit. And then when we're in the pursuit state and then we actually reach the player by entering the player's melee trigger, then that pursuit state is going to transition into an attack state. So hopefully you're starting to understand how this is going to work now, if it wasn't clear already. So probably the next thing we want to deal with is when the zombie sees the player's light. So I'm just going to copy that bit there over, and then we can just change the type. So if zombie state machine dot visual threat dot type equals, what was it, visual light, wasn't it? I think visual light. This is the second most important threat to the zombie. Well, we're not going to go into a pursuit state when this is the case. You see, as I just explained, the pursuit state is what we're going to transition into when the zombie sees something. It's within the zombie's field of view, which means it's in front of the zombie, and the zombie can then start charging towards it. However, that's not really ever going to be the case when it's the light that is the threat, because if the player was in front of the zombie shining a light, well, then the actual player would be the more important threat that would be set as the current visual threat, and this top conditional here would be executed. So if the player isn't visible and the threat is the light, then it must mean the player is out of the zombie's eye line but is shining the torchlight on it. So in this particular case, what we want the zombie to do is not transition into a pursuit state and just start magically running towards something that it can't see, but we want it to go into the alerted state. So if we imagine the zombie was just idling away, minding its own business, then all of a sudden the player shines a light on its back and the area around the zombie lights up, we're going to see that zombie kind of crouch down and start seeking left and right on the spot, trying to figure out where that light is coming from. So to do that, what we're going to do is we're going to set the visual light as the new target. So let's do that now. Zombie state machine dot set target, and then once again we just pass in the zombie state machine's visual threat, like so. So in a way, because we've set the source of the light source, the player's position, if you like, at the point when he was shining the light, as the new target, In a way, it's like the zombie does know where the light is coming from, but the difference here is that we're going to go into the alert state. Now, in the alert state, the zombie will start seeking left and right, and then will eventually go into the pursuit state, but only if it's been intelligent enough to turn around in the right direction for long enough, such that the light source, and I suppose then the player as well, enters the zombie's view cone. So we will return here, return AI state type dot alerted. Now, of course, when we run this, none of these states exist, so don't expect any miracles to happen. Okay, so the next most important threat, which is going to have exactly the same effect actually as the visual light type, is going to be when it's the audio threat, when there's a sound. So let me just copy and paste that line up above, because it's going to be very, very similar. So we'll say if zombie state machine audio threat dot type equals, and I think the target type of an audio is literally just audio, isn't it? Audio target type dot audio. Then we're going to set as the new target the position of the audio threat, and once again transition into the alerted state. So once again, remember how this is going to play out. Our zombie is in the idle state, and then somewhere around it, let's say right behind the zombie in the distance, a sound goes off, and it just so happens that the zombie, whilst facing away from that sound source, does actually fall within the sound emitter's sphere. So the zombie can hear it. Now what we're going to do is we're going to set the position that that sound was emitted from as the new target, and then what we're going to do is we're going to go into the alerted state. And once again, the alerted state is going to have the zombie panning left and right, and how accurate it's going to be is going to depend on the zombie's intelligence. And what it's trying to do is rotate the zombie around enough such that the target, which in this case is either the audio threat or the visual threat in the case of the light, falls within the zombie's line of sight and its view cone. And then we say that it's like the zombie is turned around and it's correctly identified where the target is. And then the alerted state, whenever this happens, be it a light source or an audio source, once its current target falls within its view cone, it will then transition into a pursuit state, and the zombie will start running toward that the source of that threat. So the final thing that we need to deal with is when it's a visual threat of type food. So I would say if zombie state machine dot visual threat dot type equals AI target type dot visual food, which remember is literally just any trigger that is on the visual layer, the visual aggravator layer, that has the tag AI food. Then we're going to do pretty much exactly what we do in the case where the zombie has seen the player. We're going to go into the pursuit state by first setting the food as the target, the visual threat as the new target that we wish our zombie to head towards, and then returning pursuit, so the zombie starts running toward the food source. Okay, so we've now dealt with assessing all the threats and what transitions should happen based on the state of the audio and visual threats. However, if there are no threats or there is no need to transition, then we just need to perform the processing for this update of this state. And that's going to be pretty simple. We're just going to say timer plus equals time.delta time. And then we're going to say if timer is larger than idle time, then return AI state type dot patrol. Save that off. Okay, now nothing's going to happen yet except us trying to transition from idle into a load of states that don't exist. But what I'm going to do for now is I'm going to select the AI entity, and in the inspector I'm going to set the idle time down to something really small, like 5 and 10 seconds. So it's going to be an idle time somewhere between 5 and 10 seconds. And just to check that this is working, the whole bit that kind of keeps track of time is, although we can't actually transition into a patrol state, because there is no patrol state, we'll debug log that is our intention. Going to patrol. Okay, so if I run this now, we should at least, none of these should be activated above, none of the threat assessment code, because we haven't created any threats yet, but this code should activate, and we should at least see this debug log print once the idle time has been expired. And of course, when we return AI state type patrol, our code isn't going to be able to go to a patrol state because it doesn't exist. So let's press play. I'm going to call up the console so we can see what's happening. You've entered the idle state for roughly 5 to 10 seconds. we should see going to patrol. There you go. And you'll notice what happened as well, that when we said going to patrol, we returned that we wanted to go to the patrol state. The patrol state didn't exist, so by default the state machine says, I can't find the state you want to transition to, so I'm just going to transition into the idle state. And of course, when we transition into the idle state, the idle state's on enter state function gets called again, the timer gets reset, a new idle time gets regenerated. So just looking at our update function once again, just to kind of give it an overview, you can see that if the visual threat is the player, we process this first. If it is the player, we set this as the new target and we go into pursuit mode to start the zombie running towards that target. If it's a light source, then it means somewhere out of sight the light is being shone on the zombie, and the zombie should go into an alerted state. So we set the target as the light source's origin, and then when we go into the alerted state, that state is going to seek the zombie left and right, trying to align it so that the visual threat, which in this case is the light, falls within the view cone. And when it does, the alerted state will then transition itself into the pursuit state, and the zombie will start heading toward the light source. In the case where an audio emitter makes a noise, we basically have an audio threat which we set now as the new position of the target. So when we go into the alerted state, what the alerted state is going to be trying to do is rotate the zombie left and right, trying to get the position that the sound was emitted from within the zombie's field of view. And if it does manage to do that before the alerted state times out, because the alerted state is going to have a kind of 5-6 second timer on it also, it will then head towards the target by transitioning into a pursuit state. However, if our zombie hasn't got much intelligence and it's just randomly turning left and right, not being able to ascertain where the sound source is coming from, we won't go from the alerted into a pursuit state. We'll just drop back into either an idle or more likely a patrol state. And then of course we have the least priority threat, which is food, which is not really a threat, more of a treat, I would say. Then we set the position of the food as the new target, and then we go into the pursuit mode, which is going to start the zombie running toward its target. Now, assuming none of these are activated, we want to stay in the idle state, at least for now, so we update the timer. And if the timer has now exceeded the idle time that was calculated as we entered this state, then we know that we've been in the idle state long enough and we should resume patrolling by transitioning into the patrol state. So we return AI state type patrol. Now, if the timer has been updated and the idle time hasn't been exceeded, and none of the threats above have caused us to transition into a different state, but then we just want to stay in the idle state. There's nothing happening really. We just want the zombie to keep doing its idle animation, and we just want to keep track of time until the patrol state is necessary. So that's pretty much that. That's our idle state done. So what I'm going to do now is I am going to put some comments on this so that when you download the script, it is a bit more readable. Now, I know it doesn't really show a lot. It doesn't also show us implementing the on-exit state. To be honest, there's very rarely a need to implement that state, but the function is available if there is any cleanup you need to do. But in this particular state, there is nothing we need to do to clean up anything when we exit the idle state. So let me add those comments. So there you go. I've set an AI state that implements a zombie's idle behavior. For the get state type function, I'll just say returns the type of the state. For the on enter state function, we'll just say this is called when we transition it into this state, called by the state machine when first transitioned into this state. And for our on update function, we'll just basically say this is called by the state machine each frame. And we're done. Our first state has been written and added to Zombie Jill. So admittedly, the idle state is not the most exciting or dynamic state to write, but it was an important stepping stone to understanding how these states that we're going to be writing over the next few lessons plug into our overall AI system. And we've seen already really that much like with the idle state, in order to add new behaviors and new states to our zombie, it's just a case of deriving a class from AI zombie state and then overriding, for the most part, just two functions. The onEnterState function, which is going to be responsible for configuring the parameters of the animator initially, and by setting these parameters we're going to cause transitions to happen in the animator and a new animation clip to play, and then of course overriding the update function of that state so that we can assess the threats and transition into the various states that we want to transition into, and of course perform the default processing for that state. So like I said, in the case of a patrol state, that might just be keeping the zombie rotated such that it's always facing or slurping quickly towards the steering target. I'm going to leave it there because time's moved on, and I am trying to get my videos a little bit shorter because I think people do better when they take things in slightly smaller pieces than I've been delivering them. So when we come back in the next lesson, I'm going to implement the patrol state, and if we've got time, we may or may not, maybe even try and squash another state as well into that lesson. So thanks for listening, guys. This has been Gary Simmons of the Game Institute and the Dead Earth series. I will see you next time. Bye bye now.